Alright, let's look at another thing that'll help you with this project, and that's some of the approaches to dealing with each of the individual questions. Now, questions 2 and 3, these are two sample hypothesis tests, confidence intervals for different means, and that's the same for questions 6 and 7, so you should be able to do those. I'm not going to spend much time with that. But question 4 and 5, this is a chi-square goodness of fit test. This is something that we haven't talked about that much yet. We've only been looking at it for a week in class, and we haven't really done them in StackCrunch. So let me show you what we can do with those. And I'm going to look at question 4 in this example, where we want to consider, is there a difference in the frequency of tornadoes in the coastal states of Texas, Louisiana, and Mississippi, Georgia, and Florida between El Nino years versus non-El Nino years? In StackCrunch, one of the things we've already done is build the alley, and I'm going to go ahead and just use that information instead of the coastal states because I have it here. And we want to see, is there a difference in the frequency of tornadoes? And remember, frequency isn't just another word for a count. So to do this, we actually need to get some information by hand, put it back into StackCrunch, and then we can get StackCrunch to give us some answers. So I want to go to stat tables, contingency tables with data, and my row variable, I want to pick out El Nino for the El Nino years, and my column variable is going to be alley. So when you do this, you'd want this to be the Gulf Coast states, but for an example here, I'm only going to use these. You can get whatever you want, the expected counts, percentages, whatever. I want to add expected counts, and here's our output. Now, this table is testing something with a chi-square value that we're not interested in right now. This is seeing whether or not the distribution of tornadoes in Tornado Alley are the same for El Nino years versus non-El Nino years versus the rest of the country. We are only interested in the ones for Tornado Alley or the Gulf Coast states when you do this for your project. So when I look at the columns, that's where I know I have my alley information, and so this is the only one I'm concerned with, this column right here. So I want to kind of put this into my memory, write it down on a scratch sheet of paper, and we read these as the top is my count, and then my expected value is underneath, and then in bottom I have my observations and my expected value. Now, the real question is, are those the correct expected values? And the answer is no. So back into StackCrunch, I want to take variable 15. I call this my observations, and I want those two values in there, the 1899 and 1257. Those are my observed values for the number of tornadoes in El Nino years versus non-El Nino years restricted to Tornado Alley. What are my expected counts? Well, if we think about what years we have 4 out of the 9 years in the data set are El Nino years, and 5 out of the 9 years are non-El Nino years. So we want to see an even distribution. So if I go back to closed out, create this again. So I've created a table again, and I'll also pull the total here because that'll be useful in a moment. I know how many tornadoes for non-El Nino years, how many tornadoes for El Nino years. And now I need to get my expected counts. And I should see that 4/5 of all tornadoes happen in El Nino years, and 4/9 in the El Nino years, and 5/9 in non-El Nino years, because that's my representative samples for those years themselves. So I'll come over to handy dandy calculator. Where did I put my calculator? I thought it was on the screen. Yep, there it is. And I know I have a total of 3,156 multiplied by, and I'm going to use this list to help do this quickly. So I should see for an El Nino year 1,402.667, and non-El Nino year I should see 1,753 and a third. Yep. So coming back to StatCrunch, close this column. I want to work on variable 16. I want to rename this as my expected counts, and I should see 1753 here and 1402.667 here. Now to do the chi-square goodness of fit test, we go to stat, goodness of fit, chi-square test. My observed values are in the column I called observed. My expected counts are in the expected count, and calculate. And there we go. I get my chi-square value, I get my p-value, and I see here that no, it's not what I think. The tornadoes in Tornado Alley for this data set are underrepresented for El Nino years. It appears that during an El Nino year, the frequency of tornadoes is actually less than what's expected, and consequently they're higher. The observed number is higher than what's expected for the non-El Nino years, assuming that it's the same distribution every year. And there you go. That's how you want to approach question 4 and consequently 5 in the homework or in project 2. And if we look at all the questions for the project, this will be the same thing that you want to do in 10. Very, very similar. You will use this function here to get estimated probabilities for the different categories. From there you can put in your expected values, you can get your observed values through the contingency tables or frequency tables, and then do the same chi-square single test. And there you go.